video overview of the scientific reasoning rubric, which I have designed for my Psych 4304 class. I designed it to support Keith Stanovich's How to Think Straight About Psychology, which guides undergraduate students through the processes of applying scientific reasoning to the social sciences and psychology in particular. Now, I have gone through and selected, let's see, 1, 2, 3, 4, 5 different competencies that reflect, in my opinion, scientific reasoning. And I have described them in terms of their application in the social sciences. So you'll recognize, if you're a scholar of higher education, you'll recognize these competencies from the Association of American Colleges and Universities, their value rubrics. So each of these competencies support bigger, more general learning outcomes, of which scientific reasoning is not one of theirs. It's one that I've used. But I've pulled those competencies from problem solving and inquiry and analysis and possibly one other. And so the way you read these rubrics is starting from right to left. Each competency supports the outcome, but the very far right part of the far right column of each row represents the lowest ability of that competency. And so this first competency is evaluating conclusions or hypotheses. So if you're asked to evaluate someone's hypothesis, which I like to do in class, or evaluate the conclusions that someone drew from available evidence or data, so that you read a conclusion and then compare it to the data that's there and then decide, does the conclusion sound plausible, and so on. So at the far right level, I usually see very little effort, or maybe the student makes something up that doesn't really answer the question at all. So that would be a 0, and so that would represent no achievement of the learning objective. And then the level 1 is like the very basic achievement of that objective. And then ideally through the semester, students build on it and finally get to the level 4, where they're at the absolute highest uppermost threshold of exhibiting that competency. So the evaluation of conclusions and hypotheses represents one of the highest cognitive skills that can be shown. So if we look at Bloom's taxonomy, I don't have a picture on me right now, but if we look at Bloom's taxonomy, the simplest learning objective or the simplest learning outcome is memorization or having knowledge. I know something to be the case. I can memorize a bit of information. Now, we see that as an achievement in elementary school when students learn their colors, they learn their shapes, they learn their vocabulary words, maybe they learn new definitions. But when we get into higher education, the level of achievement is much higher than that. Now, a lot of courses have knowledge level questions, knowledge level assessments, but we should be looking much higher than that. We should be aiming much higher than that. And so using these rubrics is a way to help us accomplish that. So evaluation is one of the highest levels. Interpretation is not quite as high as evaluation. So actually the interpretation of data, the interpretation of a graph, of a mathematical symbol or an equation wouldn't be as hard cognitively as evaluating evidence or evaluating hypothesis. So let's look at interpretation just as like the general example that I'll use to how to interpret these rubrics. At the far right end, remember, of this row, so the far right column, there's no attempt to explain information. So maybe you see a graph, and I'm trying to think if I have, actually, I think I can pull up a graph that I used in class. So here we actually have a graph, and I didn't make that float, so let me do that really quickly. So we have this graph here. I've asked students in class, this is emergency department visits for non-fatal self-harm among U.S. teens. This was in 2022, published by the National Center for Injury Prevention and Control. If the question asks students to interpret this graph, a zero response, so it's about non-fatal self-harm, a zero response might be to say something like this: non-fatal self-harm is a problem, and we need to help kids who want to self-harm because that's a serious problem. So what I just did was kind of riffed on the topic, and I didn't even consider the graph. And so maybe what I said is accurate, maybe it's heartfelt and serious and important, but I haven't actually addressed the question at all. So that would be a zero on the scientific reasoning. So does not attempt to explain the information. The next level here is one step up. We see an attempt to explain the information that's presented in this case, a graph, but draws incorrect conclusions about what the information means. So if I were to look at this graph, remember the first example just said something randomly about how non-fatal self-harm or self-harm in general is bad. This student would actually try to interpret what's there. So girls are 3 times as likely to self-harm than boys. They might say something like that, which isn't actually what the data says, and so it would be more like 2.4% if we calculated it. But girls are 3 times more likely in 2010 than they were, or now, than they were in 2010. That would be an accurate interpretation of this data. If someone looked at this graph and said, non-fatal self-harm has been stable for the last 20 years, well, that would be inaccurate because the graph shows that boys and girls seem to be, the trends are going up. If someone looked at this graph and said, boys are more likely to self-harm than girls, that's not what this graph would say. If someone looked at this graph and assumed that depression would explain more non-fatal self-harm among girls than boys, well, the graph doesn't actually say that. It might be true. It might be one of the conclusions we could draw, but they've ignored the actual information presented in this graph. So what I've tried to do there is show an attempt to explain information, but an incorrect attempt. Looking at some of the examples that I've had in my assessment role at Albany State University, I've seen people misread or misunderstand the x-axis, not understand what the y-axis means, and so there were interpretation problems on how to read the axes, how to read these regression lines, what the regression line means, what they mean, what the scale means. So they might see this, it says per 100,000, but they might think that 600 people had non-fatal self-harm, or 600 girls. But this would mean considerably more than that. Or they misread the title. And so maybe they look at this and think it's about depression or anxiety, when that's not actually what the topic is. All right, so let's go back to the scientific reasoning rubric. I've given you examples of a 0, of a 1, so let's move on to a 2 example. This student provides somewhat accurate explanations of information, but occasionally makes minor errors related to computations or units. Going back to my previous example, I would actually say the second example that I gave, where they look at this and say girls are 3 times as likely to self-harm in 2022 as boys, that would be a minor mistake. So that example would actually be a 2 on this rubric, and so I misspoke when I gave that as an example of a 1. Because the direction of that trend is correct. Girls are more likely than boys, but the magnitude was only slightly off. If they said girls were 300 times more likely, well, that would be a factor of 10 off, or I guess 30 times more likely, or a factor of 100 off for 300 times as likely. That would be more than a minor mistake. So if someone looked at this graph and said, through the first 6 years, it remained exactly the same, well, it remained pretty level compared to the rest of the slope, but it did change. There were some variations, including the record low during this period. So having a somewhat accurate interpretation, but maybe missing something essential, or making an important mistake. Or how about it says, you can't see it, but ages 10 to 14. If they were talking about young children, maybe they misread the title, but they got everything else right, but they just didn't take into consideration that it was talking only about girls between 10 and 14, not girls between 0 and 14, or young women. Might be some more mistakes. All right, so that's a 2. Moving on to a 3. Notice we're getting better each time. And in order to achieve this competency, you have to really understand how to read a graph in this example. It may also be read a table that lists things like averages, standard deviations, p-values, and so on, and interpreting what those mean. So you have to have, depending on what course you're in and what the goals are, what sort of data you're looking at, you need to know how to read each of those different formats of data. All right, number 3, level 3, provides accurate explanations of information presented in mathematical forms, period. All right, so there's no mistakes. Going back to this graph, to be able to say that since 2010, and honestly, if you just read the 311% increase since 2010, you don't need to interpret the information, so this would make it a poor question. I'd have to delete the interpretation that the author of this graph, who was Jonathan Haidt, by the way, I'd have to delete that section so that people would actually have to come up with that interpretation themselves. But if they looked at this graph and said there was a pretty consistent increase over a period of 12 years of both boys and girls ages 10 to 14 of emergency department visits for non-fatal self-harm, that would be accurate. What I did was just interpreted one part, or I just interpreted one part of this graph. I could also say that in all years measured, girls are more likely to visit the emergency department for non-fatal self-harm than boys, than ages 10 to 14. Again, that's an accurate interpretation of the information in this graph. I haven't made any minor mistakes, which would be a 2. I haven't made any fundamental mistakes, that would be 1. And I haven't completely avoided an interpretation, which would be a 0. So how do we get to level 4? Level 4 is identical to 3, except that this person makes appropriate inferences based on the information. So that's taking another step. And one thing my students recognize very quickly is that 1 through 3 are focused only on the information without going beyond it. If they were to introduce new information to interpret the graph, they're adding data that's not actually there. But at level 4, once we have honored the data that's represented in the graph, we haven't added to it or subtracted from it or changed it in any way, now we can say, here's the data, here's what it says, here's what it means. That last part, what does it mean? What conclusions can you, as a scientific scholar, draw from the data that's there? And Jonathan Haidt, when he presented this, it wasn't just these shocking statistics, and they are shocking. He had a narrative that accompanied it, and he looked specifically at this period of 5 years, and he looked at this for depression, for anxiety, among children, among teenagers, among young adults, among older adults. He looked at it in a whole bunch of different demographics to tell a story that social media has fundamentally changed Generation Z in particular, but their social habits, their emotional needs, and their emotional self-regulation. So it's a combination of parenting styles and social media that he uses to explain these graphs. The graphs can't be changed. That's data that's been collected over a period of years by national institutes. But what those mean can be left up to us as scholars to draw inferences. And keep in mind that this is not experimental data. This is just existing data, and we can look at correlations between years and incidence levels. We can't make causal predictions, but if enough of them line up, they may tell a story, and that's what that last part asks about. Makes appropriate inferences based on that information. I had one student look at this graph and say, I think I know why girls are more likely to visit the emergency room for non-fatal self-harm than boys. And her explanation, so her interpretation was consistent with the data, but she had an explanation to give as to why that's the case. That's not here in the data. So she drew an inference to help us better understand what this is. And her inference was that boys are just as likely to self-harm, but that boys are more likely to succeed at suicide. So that girls may self-harm, or maybe they're attempting suicide but don't succeed, whereas boys do. And I told her, if you look at the suicide data from the same period, boys in all countries are more likely to succeed when attempting suicide. So these curves are inverted, so the boys would be higher than the girls with fatal self-harm. And that helps us understand what this graph by itself almost seems like girls just self-injure more than boys. But if we consider the suicide data, we can see that maybe it levels out a little bit more. It's closer in terms of self-harm, but suicide incidence is higher among boys. Another interpretation might be Jonathan Haidt's, that social media started around 2008 to 2012, and so most girls growing up were using it, boys were using it, and girls were really impacted more so than boys, but boys were still impacted, so you can use that. What you're doing again is following the data and then suggesting what the trends mean. And you can really take that any direction. If you're familiar with something that happened historically in 2010 or even 2009, that would help us understand that trajectory or that growth over the years. Maybe expectations about growing up changed throughout the years. But what we add to it, once we've honored the data that's there, any inferences that we draw helps people who are listening to us understand what it means. The data itself is just data. It's raw, it's analyzed data and results. But what does that do for us? How can we use those? That's that next level. So it really invites the researcher to be creative, and that makes it one of the more exciting aspects of the research process. So that was me running through the 5 levels of this rubric. But keep in mind, the rubric has 1, 2, 3, 4, 5 different competencies. So depending on what the question is asking, you might be evaluating evidence or selecting evidence, drawing conclusions or evaluating existing conclusions. We did an interpretation, but also the evaluation part up there, explanation. We can see graded levels of improvement in terms of answering those questions in all of those competencies. And I'm hoping that this walkthrough video was helpful.